Hi. Uh, so this is a solve with a session for week 2, and let's wait for like a few more minutes for others to join, and then we'll start. I hope I'm audible and the screen is visible. And am I audible?
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt in practice assignment of 2.2 week 2.
Okay, so we have a doubt session separately, right? Is it already done, or I think it's done, right?
Yes, ma'am.
Were you not present in that session?
No, ma'am, I didn't attend that.
That's what doubt sessions are for. Okay, we'll take your doubt towards the end. Is that okay?
Hello, ma'am.
Yes, ma'am.
Okay.
Excuse me,
Yes.
ma'am.
Yes.
Ma'am, I have a doubt in week 1 GA.
Did you attend the last doubt session?
No, the last doubt session is before the result of GA coming.
Okay. We'll take
Now,
that
the
up
problem
towards the
is
end.
not in the question concept. Like the first question, the answer is showing all four options, but I think option D is only correct. So, if you check the first
Okay.
question only, so
Okay, let me have a look. Just 1 second. Week 1 graded assignment, right?
yes, first question.
Okay, just 1 second.
I also have a doubt in week one graded assignment.
Let me open the portal first. Just 1 second. Yeah, which question did you have a problem in?
First question.
First, yeah, and okay, can we take up the doubts towards the end? Because I think there are a few questions, few doubts in graded assignment from week 1, and then there are a few from practice assignment 2, from week 2. So we can take those towards the end. We'll have some time towards the end. We can have those questions there. Is that okay? 49 students. Okay. So we'll start with the questions now. Give this question a read and give this a try too. And then we'll discuss this here. It shouldn't take very long. This is a solve with a session, so we'll be doing questions here from week 2. And then once we're done with the questions, we can have your doubts too. So I hope this one's done. And we can, is anyone done with this one? Is anyone trying this question? I'll need a few people to respond so that I know whether you're trying, not trying.
Ma'am, is it 0.4?
Okay, let's see if it's 0.4. 0.4. Okay, let's see which one's correct. So the question is, we have some 250 football players, and then this is how they're distributed. And you have to find the relative frequency for X, Y, and W, right? So anyway, we cannot find the relative frequency for the individual ones. X, Y, and W, we cannot find these numbers. And we cannot find the relative frequencies either. That's not possible. That's why we've asked to find the combined relative frequencies. So this is 90. So the total number is 250. And here the total
Now,
is 90 plus 60. So it's 150. So you subtract 150 from here to know what's X plus Y plus Z. This is the total, right? So you will have 100 here. And then for the relative frequency, you have to divide 100 by 250, right? So it's 100 by 250 for the relative frequency of X, Y, Z combined. So this is going to be 2 by 5, which is 0.4. So it should be 0.4. Is this clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Then we have this as the next question. Give this one a try. And I'll suggest you to find everything here. You can find everything. So find everything. All the variables X, Y, P, Q. And the total too, obviously.
Excuse me, ma'am, I need to ask one thing.
Yes.
Ma'am, like like the week second assignment date is tomorrow's last deadline. Ma'am, it will be not extended or what?
I am not aware of the extension of dates for graded assignment. So I'll check with someone and confirm,
Okay, ma'am. Thank
maybe
you.
towards the end of the session. Okay.
Okay, ma'am.
Find all the variables here, the unknowns. And drop your answers in the chat box.
and QH 0.36.
Okay, let's see. So from what we know, first we should try to find the total number. Okay. And that would be the easiest. We have two values here, this one and this one. We can use this data too, this one, the last
And
one, to
1000.
find, yeah, to find the total. So let's see what's the total.
My answer is 0.6.
Okay. You have total number of surgeries here are 240. And the relative frequency for 240 number of, let's say the total number of surgeries here, this total, let's call it T. Now, if this total is T, Then 240 by T gives you the relative frequency for this gastroenterology. This should be 0.24. And then to find T, you will just need to do 240 by 0.24. That's going to give you 1000, right? Yeah. So this is what you will get. So the total is 1000.
And P is 0.18 and Q is 0.36.
Okay, let's see. Then you have 180 number of surgeries here in orthopedic. Orthopedic surgeries are 180 and the total number we already know is 1000. And this should give you the relative frequency, this one, this relative frequency. So this should be P. P should be equal to 180 number of surgeries here by the total number of surgeries. That gives you the relative frequency, which is P. So this is, you will have 0.18. So P is 0.18. Then similarly, you can find this thing X. And we know that the things are just getting, by now we know that the things are either this number is getting divided by 1000 as we did here. And this number then should get multiplied to get this, right? You can do it by the formula too, but you can just do it by looking at it. This number gets
X is
divided by 1000.
220.
This number gets divided by 1000 and then you get the relative frequency. So X should be equal to 0.22 multiplied.
220.
Yeah, so it will give you 220. So X is 220. And now your total is 1000. So this is 180 and 220. So this is 300, 400 and 500, 600, 900 and 940. So this just leaves you with 60 then, right? The total is, except Y, the total that you will get is 180 plus 220. So this is 180 plus 220. Y is 1000 minus 180 plus 220 plus 240 plus 300. So this is going to give you 60. That means your Y is 60. And because this is 60, so this should be, we divide this by 100 to get the, 1000. To get the relative frequencies, this will be 0.6, 0.06, right? So we now have all the unknowns here, and we were only asked about Q and then the total number. That's it. So is this one fine to everyone?
Yes, ma'am.
Okay. If anyone has anything to ask, you can unmute yourself and ask. If there's nothing, we can move to this question. This is the next question. Give this one a try.
I mean, cannot be
No,
ordered.
it cannot be median because it is
Okay.
nominal.
Right. So this data is not an ordinal data. This is an nominal data. You're right. And this is for you to find median, you need the ordinal kind of data, right? So the scale should be ordinal, and that's not the case here. Ordinal means you should be able to arrange them. That means T and H should have had, if T and H had an order, then you could arrange them, right? If let's say if H was greater than T, then you could arrange this as T, T, T. If this was given somehow that this H is greater than T, or it's better than T in some sense, then you could have written all the T's together. So the number of T's are 1, 2, 3, 4, 5, 6, 7, 7 T's, and then the remaining H. And then you can find this is about the median, right? Yeah, and then you could find the middle value. Like what observation is the middle observation when you arrange them in ascending or descending order. But that's not the case here. You cannot arrange them in ascending and descending order because you don't have an order here. order, that means this is not an ordinal data. That's why about median, you can say nothing. Can't be found. Can't be found. So that's all you can say about the median. You cannot find it, right? Because it's an ordinal data. Because not an ordinal data. That's it. Let's come to the next one. This is if Rohan wants to show the results of a class president election in school, then for this purpose, which graph will be the most appropriate? So you have some graphs that you've studied, bar graph and then pie chart and then Pareto and all. Which one do you think should be the most appropriate one?
Pareto chart.
Pareto.
Right. So Pareto fits here because you need to find and the one with ascending one or descending one works too, but sorry, the descending one, right? So if you have bars like this, you'll just know who got the most number of votes. So Pareto charts work perfectly here. Does anyone have a doubt in why Pareto works here and why the others don't? It works
Yes,
because,
please explain.
yeah, okay. So we basically have, there are only three options, I guess. The one's Pareto, then we have bar chart, and then we have pie chart. So in pie chart, that does not, when do you use pie chart? Pie chart is basically used when you have to,
Share of vote.
okay, yeah,
Percentage of
when you
share.
have to
Thanks.
compare the shares, or you can say you have to compare the relative frequencies. So when you're comparing the relative frequencies, as in what share does one have and all of those things. Like let's say you have a pie and then you're sharing it with people. So who's got how much of it? That's when basically when you're discussing the share of something as from the total thing. That's when you use, you can unmute. Okay, that's when you use pie chart. So this is basically in statistics terms, you say you use it to compare relative frequencies. When you have to compare relative frequencies, relative frequency comparison is only done when you have to find the share of each person or each thing involved, right? So this is when share comparison is involved. Whose share is what? Like let's say three people have contributed money and you have to check who has contributed how much and you have to compare them, compare their shares with each other. Then you use pie chart. Bar chart is basically, it's to compare frequencies. This one is to compare frequencies. Or you can say that it's to compare frequencies or the observations with each other, the number of observations. So compare counts or whatever you call it in simple words. Compare counts with each other. Like who's gotten more, that's it. This has nothing to do with shares. Who has contributed how much, that's not what we're doing. We're trying to compare things, as in let's say you have gotten some marks and then someone else has gotten, or let's say this is how many people have gotten 20 marks and how many have gotten, just 1 second. How many people have gotten 20 marks and how many have gotten 40 marks. That's when you use bar charts to see how many of them have gotten what. Basically, if you can remember this thing, that works too. This is to compare frequencies. This is to compare the share. And then Pareto is when you have to arrange things. This is one kind of bar chart only. Pareto comes under bar charts only, but it's a special kind of bar chart where you put the bars in ascending order or descending order. So either in descending order, this, or in ascending order, this. That's when you call it a Pareto chart, and that's used when you have to see who has gotten the most, right?
Hello,
Who's
ma'am.
leading, who's doing, yes.
And if ma'am data is ordinal, means we have to preserve the order, so it is Pareto or bar.
Yeah, that you can see it in that manner also.
So will we it Pareto chart or bar chart? Because we
You
can
have
also.
to, yeah, you'll use Pareto chart here because you need arrangements here, right? Arrangements as in who's gotten the most number. If it's an election, you need to know at a glance who won, who lost, who got the most number of votes and all, right?
No,
When
not
we
for this
want
case. Not
when
for
we
this
want
case.
to preserve the order, like number on the dice 1, 2, 3, 4, then we use bar chart or Pareto chart.
Sorry, what? Pareto chart is to know if you want to know which has gotten the most frequency, where does the most frequency lie, and where's the least frequency, when you have to find the most number of things, most number of counts or observations. That's when you use Pareto chart. Otherwise, you use bar works there.
Ma'am,
All
but if we want to know the highest and the lowest, but also we want to preserve the order, then we use bar chart.
okay, that works. Yeah, if you want to know the highest, and because bar chart automatically there are bars there, you can automatically see which bar is the longest bar, right? In this one too, actually, you can use bar also because anyway you will be able to see who has gotten what, who has gotten the most number of votes by just looking at the bars.
Okay, ma'am.
That works too. Is this fine?
Yes, ma'am.
Can we move to the next question? Does anyone have any doubt in this one? Where to use the three?
Ma'am, about the relative frequency, can you explain that again, ma'am?
Okay, so the relative frequency thing is, let's say you have you have a group of friends and you have contributed some money, right? Or let's say you have to compare the shares of each person. So when you have to compare the shares of people, that's when you do pi. That's why you
Okay.
why do we even use relative frequency? The point of relative frequency is to see that out of one, who has contributed how much, right? What's the share of
Yes, ma'am.
each case there, right?
The
That's why
first
you
one.
use relative frequency. So if someone has 0.1, let's say someone has 13, then 15, then 14, this becomes difficult to compare as to who has contributed how much. So you
So as
just
a
have
whole.
relative frequency, yeah, to see who has contributed how much. This helps. That's why this is used. The pi thing is used, and you use in even in making a pie chart, you use relative frequencies, right? Which you don't in bar.
Yes, ma'am.
That's why this is for share comparison only. That who has contributed how much, whose share is how much. That's what this thing is for, pi thing.
And Pareto is for the maintaining the order, right?
Yeah, it's for maintaining the order when you have to see which one has the highest, which one has the
Okay.
lowest. This one, if there has to be just one answer, because it ideally it should have both. Both are fine. But if you were to give just one answer, it should be Pareto. Because
Okay, ma'am.
you've been in the result thing, you need to know who has gotten the most number of views. And you've not been asked to preserve the order or anything, right? Like the order in which things appear. If this is, let's say this is person A, this is person B, this is person C, then you're not being asked to preserve the order of these, right? That's not in the question.
Excuse me, ma'am.
Yes.
Ma'am, does the total of relative frequency is always equal to 1? Or
Yes, it's
sometimes
always
if
one.
it is not equal to 1, then what does it mean?
It means nothing. It's always one.
Okay, ma'am.
Okay. So can we move to the next question?
Yes,
Yes,
ma'am.
ma'am.
Okay. This is the next question. Give this one a try.
Ma'am, option first and third.
Ma'am, mode is C.
And median is also C.
Okay, let's see.
First and third.
So we have an order here. This is an ordinal kind of data. That's first thing. That means you can find the median as well. So median is this this automatically becomes incorrect. You can find the median, and for ordinal data you have both tendencies, both central tendencies available. One is median and the other one is mode. You have both available. So let's come to the first. You have to find the mode and median of this data. So for mode, what you do is you find the most number of the highest frequency, right? And the highest frequency here is this 35. So it belongs to C grade. That means C has the most number of mode is basically the most number of observations. That's it. The most number of observations are C. That's why the mode should be C. This one's correct. Then about the median thing, you arrange this in ascending or descending order. So we're going by we can go by the descending order. Let's go by the descending one. So let's start with A. So you'll have A 15 number of times. We obviously don't have enough time to write it. Number of times. Then we have B followed by B, which is 20 number of times. Then we have C written 35 number of times. And then we have D written 15 times. And E 6 times. And for you to find the median is basically the middle observation, right? And the total number of observations are, this is 15, 35, 45, 50, 70, 85, and 91, right? So the total number of observations are 91. And for you to find the median for an even number, it's 90 by 2 and 90 by 2 plus, if it were 90, you would have 90 by 2 and 90 plus 90 by 2 plus 1. So these two would be considered middle observations. And when you have 91, you just add 1, make it even, and divide by 2. This will be 92. And the middle observation would be it's 6, right? 46.
46.
So 46th observation would be the middle observation. Is the median. So this is 15 number of times, then this is 20 number of times. So this becomes 35, then this is 35 number of times, so this becomes 70. So till
Ma'am,
B, yes,
ma'am, odd number of terms should have one median, right?
yeah, yes.
But you mentioned two.
No, that was for when you have 90. I said when you have 90 observations, even number of observations, then you will have two middle observations, 90 by 2 and 90 by 2 plus 1. That's
Okay.
when you have 90 observations. That's why I raised it. Okay. So this is A 15 number of times. Then you have B some 20 number of times. So this total becomes, from this A to this B, there are 35 observations, right? And then, so till this part, it's 35. And then when C gets over, C starts here on the 36th one. And C gets over on the 70th one, right? Because C is written 35 number of times. You will repeat C 35 times. This will get over here on 70th. And the median is 46th observation. That means it lies somewhere here between the first C and the last C. And that's again a C, right? Let's say you have 46th observation here, that will be C. So your median is C. Is this okay? Is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Can we move to the next one? If anyone has any doubts so far, You can unmute yourself and ask. This is the next question. Others can give this one a try.
For even number, the median is 90/2 and 90 plus 1/2, right?
Yes, 90/2 and 90/2 plus 1. It's the 90/2th
Two
observation and the
medians.
next observation. So it's 90/2 plus 1.
But for even number.
Yeah, for even.
And in our case, it's just 91 plus 1/2.
Yeah,
our case. Okay.
this is 91 plus 1/2. You have to complete this table. So the missing values are this one's missing, this one's missing, this is missing, and this is missing.
The total student is 50.
Okay, let's do this thing here. You have only one category where you know both the frequency and the relative frequency, and for you to find out the total, you need both, right? So,
Ma'am, for
yes,
60 to 60 and 70 for 0.3.
okay. So this is frequency. Let's see if this is, you're saying this is 0.3, right? Let's see.
The first one is 8 frequency, 40 to 50.
Okay, let's see. So your this is the formula: frequency by total numbers, total number of observations. By total, I mean total number of observations. That means the total of all the frequencies. This gives you the relative frequency. So using this thing, your relative frequency equals to 0.124. Your frequency equals to 12. And then you have to find the total. Let's call it T.
To 10.
Ma'am, for last row is 5.
Okay, let's see if this is 10. And for the last one, if this is 5. Let's see.
5.
So this will give you 12 by 0.24, which
50.
gives you
15.
Yeah, 50. This gives you 50. So your total is 50. Then let's find this one. Then you can find all the others, right? Except this one. So you can try to find this, this, and this. Out of these three, you can find any. This will
0.2.
require more information. Okay,
0.
so let's start with the first one. Yes, 0.2. Okay, let's check all these if they are correct or not. Starting with this one, this should be 8 by 50, or you can have this as x by 50 if you don't like 8. So x by 50 and 0.16. So this is going to give you x equals to 50 times 0.16. You will have to find this value, which I believe is 8, right? So this should be 8. Then for this one, so this is 8. These two are done. Then for this one, you have 15 here. So your frequency is 15 and the total is 50.
50.
and this will be equal to, this is 3 and 10, so this is 0.3.
And 3.
So this is 0.3. Then the next thing you can find is, now these are also unlocked. You can find these two. So this is the total, should be the total of relative frequency is 1. So you have 0.16 here, 0.24. So this gives you 2, 3, and 4. So this is 0.4. This is 0.5. This is already known, 0.3. So this will be, total of these would be, we had 0.5 till here and then 0.8. So the total of all these relative frequencies so far is 0.8. And the sum of these frequency, all the frequency, relative frequencies is 1. So 1 minus 0.8 will give you this value, this relative frequency. So this is 0.2. Then you have these two missing, right? These ones are missing. You can find them. Relative frequency is 0.2 and 0.1. So when you have 0.2 here and one has 0.1 here, and the values, the total is 50 in both. Let's call this P. Let's call this Q. This implies your P is, the frequency corresponding to 0.2 relative frequency will be 50 times 0.2, which is 110. And this will be, this is Q, so this will be 5. Right. So this is 10 and this is 5. And you can check this. This also sums up to 50. 20, 30, 35. Wait. 30, 40, and 50, right? So is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, the third one, ma'am, 15 by 10 is equals to, can you explain that, ma'am, once? How do you define the relative frequency?
15 by this one. Which
Yeah,
one? This
15 by
one.
2. Yeah,
This is, we had 15 here,
yeah.
and we didn't know. I think this is what we calculate. Yeah, we didn't know this thing, right? This was absent, and we knew that the total is 50. So your relative frequency corresponding to frequency 15 is, you have this formula, frequency by total number of observations. So total is 50. Your frequency is 15. That should give you relative frequency of this one. So we have
Okay, ma'am.
applied this formula. That's it.
Yes,
We've
ma'am.
used the same formula everywhere, just in
Okay,
different, this one and then this one, that the sum of, so the formula used are, this one's the first formula, second one is the sum of relative this is the symbol for summation. So this is sum of relative frequencies is 1, and the third is the total.
yes,
The
ma'am.
total also you can calculate from here. So basically we've only used these two formulas. That's it. These two.
Okay, ma'am. Thank you.
Okay. So this is the next question. Yeah.
Hello, ma'am.
Yes.
Actually, I was having doubt in like graded assignment week 1 question number first.
Okay. So would you be not here towards the end of this session, because we plan to discuss the questions, the doubts from previous grade assignment towards the end.
Okay, ma'am. Actually, it was like only one question, the first
Okay.
one.
The first question from week 1 grade assignment. Let's see.
Yes. Should I share screen?
No, I'll just copy paste the question here. Yeah, this is the question, right?
Yes, ma'am.
Okay. So this is the education minister wants to know the status of campus placements of BTech students in different engineering institutes of India. An analyst did a survey on the randomly selected 4 IITs of India. So the survey has been done on 4 IITs from India. That means this should be the sample, right?
Yes.
This question is about sample and population. So the sample should be the 4 IITs. And then the population should be, it should be in the beginning, right? The education minister wants to know the status of campus placement of BTech students in different engineering institutes. So it's different engineering institutes of India, right? Those that are
Yes.
doing engineering. So this is the sample consists of all engineering, because this one becomes automatically incorrect, right? The sample consists of all the IITs, but we only have 4 IITs here. This is also incorrect. The sample consists of all IITs of India. This is also incorrect because we only have 4 randomly selected IITs, right? And this one says the sample consists of 4 randomly selected IITs of India, and the population consists of all engineering institutes of India. That's the population, right? All engineering institutes of India, this one. And then the sample is this 4 randomly selected IITs.
But ma'am, when we have submitted our assignment, B and C are also correct.
Now A, B, C, and D, like 4
Yes,
option
they
is
are
also
Ma'am,
correct.
correct.
in my
Yes, ma'am.
assignment, they are
Yes.
showing that A, B,
Yes,
C
ma'am.
is
Yes,
B
ma'am.
also
and C
expected answer.
expected.
Yesterday it was B and C. Today it
ABC
is like
also.
yes.
Okay, so what does the answer say? That all are correct, is
All
it?
options are correct, they are saying.
Yeah, they all are correct.
We
So
got partial marks.
that must be a mistake then. It's a mistake.
Okay, ma'am.
So we'll correct
Okay,
it
ma'am.
as soon as possible. Okay.
Ma'am, I
Excuse me,
send
ma'am.
a picture in chat. Can you see that?
Is it? Yeah, 1 second. Yes, I can see that.
So that's what I'm confused between, like how it can
And
be.
the number also detected. The
That's okay.
percentage
We'll
or no.
correct it. We'll correct it.
Okay, ma'am. Thank you.
Okay.
Excuse me, ma'am.
Yes.
So can you also please help out with the fourth question of this assignment?
Of the same assignment.
Yes, ma'am.
Okay.
Hello, ma'am.
Yes.
Ma'am, in the portal, in math also, the answer is correct. We are submitting, but the expected answer is showing wrong.
For first question, you are saying that?
Oh, in mathematics also. Not in graded assignment, but also in some practice assignment.
Okay. So if you're aware of the discourse forum, you can post your doubts there. That's what it's
Ma'am,
for. If you
ma'am,
have
I
a doubt
don't
in,
know about it.
okay,
Excuse me,
you can
ma'am.
ask someone to guide you through the discourse thing. That is the purpose of that forum, for you to post your doubts there and get them clarified from there. If there are some mistakes in the questions, you can point them out there or to the instructor directly in the course. Yes.
Excuse me, ma'am.
Yes.
I mean, practice assignment 3.2, 7th
Of
and 8th question. There is no graph or information is given, only the questions are given in 7th and 8th.
the third, you're talking about the third week.
Yes, ma'am, 3.2 practice assignment.
Okay, we can come to that later. We're not doing the third week right now. Which questions were there?
7th
Which
and
questions?
8th
7th and 8th.
information is missing.
3.2 practice assignment, right?
Yes, ma'am.
Okay. We'll make the changes.
Okay, ma'am. Thank you.
Okay. We had this question and okay. So this is the data of 5 different types of fertilizers used by farmers of a village. These are fertilizers. These are the type of fertilizers and these are fertilizers. So your case then becomes this, right? So your, okay. Amount of
Option
fertilizers.
C and D.
Where's the, I can't see the manure case. Okay, this, we have manure here. Okay. Okay. So the cases are, in simple words, what you collect about what you collect the information about are your cases. So these are your cases, right? Nitrogen, phosphorus, manure, compost, potassium, all of these are your cases. So your manure is one of the cases, right? This option is
Yes,
correct.
ma'am.
And then the amount of fertilizers okay, the amount of fertilizers
Variable.
is
Variable.
Also
this
correct,
one,
ma'am.
and this is a variable, right? It's varying here depending on the case. So this is the variable. Then about the other options, nitrogen is not a variable. This is a case.
Nitrogen is case.
Rice,
Yes, ma'am. Rice
rice is
is
also
a
not a case.
variable.
Only these are cases. Only these are cases. So rice is not a case. Nitrogen is not a variable. And inorganic is a case. These are not cases. Only these are the cases, right? We've discussed this. Is this okay?
Yes, ma'am.
Ma'am, can we generalize it that generally the first row is always the case?
No, not generally the first row. If you swap these two, you mean the first column, right? So
Yes, of first
not the
column,
first.
sorry.
The first column is not always the collection of cases. If you will swap these two columns, if I'll have type of fertilizers first and fertilizers later, then still this collection is the collection of cases, not this one, because these are varying, right? These are variables. You have two options, inorganic and organic. These are variables.
Okay,
Variables
so
as
this is extra
these, in fact,
information
these are
about
not even
this.
variables. Variable is this, and these are the choices that you have. Like this variable can take this value, this inorganic value and organic value. Your types of fertilizers is a variable which can take inorganic values or organic values, right? And cases are what you collect information about. You're not collecting information about inorganic and organic fertilizers. If that were the case, you will see something like this: types of fertilizers, and then under this, in the column, you will see inorganic and organic. These, firstly, they won't get repeated because you don't repeat the cases, right? You're collecting information
Ma'am,
about
thank
this
you.
thing. Why will you repeat it 3 times? You'll collect
Yes,
all
ma'am.
the information here. That's it.
Okay,
Is this
ma'am.
Thank you,
okay?
ma'am.
Okay.
Ma'am,
You're not clearly audible.
Ma'am, then what about area of fields and types of crops? Can you hear me, ma'am?
Yes. So area of fields and types. See, areas of fields is all of these are variables. Type of fertilizers, this is a variable. This is also a variable. Types of crops is also a variable. Amount of fertilizers is also a variable.
ma'am,
These
ma'am.
are, yes.
Fertilizers is the variable and nitrogen phosphorus mature in all in this case and type or and inorganic organic in this value of the type of the fertilizers. But the fertilizers is variable, inorganic inorganic all is these values.
Yeah.
I'm right.
Okay. So inorganic is what's a variable. Variables are basically what's varying, right? So this is inorganic is a fixed thing. It's like if x can take 1 and 2 values, then you say x is a variable and 1 and 2 are the values that it can take, right? So in a similar manner, types of fertilizer is the variable and the values it can take are just values. So inorganic and organic are not variables, they're values,
Not variable. Yes,
right?
ma'am.
Yeah,
That is
they're
value.
fixed. How can they be
That is
variable?
values.
Yeah,
Yes, ma'am.
okay. Is this okay?
Hello, ma'am.
Yes.
Can area fields can be discrete in any of the condition?
Area of field, see, area is
No.
generally a continuous variable. So unless
Continuous.
mentioned, it will stay continuous. Otherwise, they'll mention it.
Okay, so if all values are discrete, then it can be discrete.
Yeah, if they'll see, if you look at this data, they look all discrete, right? If I'll collect this 1, 2, 1.5, 1.3, and 1.6. Now, if only this collection is the data, then this is discrete collection. But your
This is
variable isn't
countable.
discrete. Okay, give me a minute. Let me complete. This collection, forget about this thing, forget about this column for now. Only focus on this collection. If you have been given this collection and I don't know what this thing is, right? I have only been given this. Let's say I have a variable x and I say x can take values from this set. Then this collection is discrete, right? But if you will mention that this is not the collection of only these quantities, it's the collection of all the possible areas. All possible areas. They can't give you all type of areas, right? 1.7 could also be area, 1.712365. This can also be the area. They cannot give you every value in the table, right?
Right,
All
ma'am.
possible areas. If I'll take this all possible areas, then this becomes continuous. Or if I mention, so the point that I'm trying to make is, if I say that X belongs to this set, then this set is called the collection of discrete quantities. This is a discrete collection. Do you see any continuity here? If only this is the set, then we call something
Can you
continuous
explain?
when there are two things and all the values between these two things are available. 1.6 is not available, right? In this set, 1.6, it's available. 1.7 is not available. Okay. So there are a lot of values not available in this set. I'm not talking about this column. We're just talking about this set for now. That's why this thing becomes discrete. But when we say that this is the collection of areas, this is continuous because we know this is the collection of areas, and areas can take any value, right? Except the negative one, obviously. That's why it becomes continuous. Is that okay?
Ma'am, a little confusion. Can decimal numbers can be called discrete?
Okay, in simple words, what discrete means is, discrete means when you do not
Ma'am, can I say
discrete.
something?
Yeah, go on.
Suppose can you say that you have 1.5 bottle. The, you only can say like you have one bottle or two bottle. This is discrete value. You
Yeah,
can't measure in continuous value. And suppose you have your height. Your height can be 5.5 feet or 5 feet. This is continuous now.
yeah, right. But
Ma'am,
we were just trying to get at the definition of discrete. And let's say if you do not know, this step comes later. First, you should know what a continuous variable, what's a continuous collection, and what's a discrete collection. So continuous collection is basically when you have two variable, two okay, two things fixed. Let's say this is 2 and this is 10, and you have every value between these two available in your data. Then is when you say that it's a continuous data. So let's say when you have heights, as you spoke about heights, because you have every decimal. If I'll have 5 point, or let's say someone could be 160 centimeters tall or 160.123 centimeters tall, right? If you will measure it accurately, you can find every value, right? That's why it's continuous. So when all values are continuously available to you, it's called continuous data. Otherwise, it's discrete.
excuse me, ma'am.
Yes.
Ma'am, the values belonging to X set is in decimal, not in whole number. So how the values can discrete?
Discrete is that's not, you cannot restrict discrete to just whole numbers. That's not how discrete thing is defined. Discrete uh, collection is defined. Discrete collection is anything which is not continuous, which you, or okay, let's not get into that detailing because you don't need it for this course. But when you have finite, in simple words, any collection that's just finite is going to be discrete. Okay, let's not even go there because I don't think that has been discussed in your course. Let's stick to this thing. The things that you can continuously measure are in the continuous category, and the things that you cannot continuously measure, like the number of bottles, number of students, and those type of numbers, though they come under discrete. Is that okay?
Yeah, thank you, ma'am.
That's it. For this course, this is enough. Okay. Coming to, can we move to the next question now?
Yes, ma'am.
Okay. So this is the next question. In a survey of 100 patients, diabetes has a relative frequency of 0.35. If you are constructing a pie chart, how many degrees should the slice for diabetes represent? So give this one a try. Or should we directly do this one here? So how do you, if you have relative, let's say you have some values here, and then you have frequency here for observations, then their frequencies, the number of times they have been observed, and then the relative frequency, right? Which you calculate out of 1.
Yes.
And then you can just generalize it to anything, like you can find the percentage too. You can do that too, and you can find it out of, this is out of 1. So relative frequencies are out of 1. Percentage is out of 100. And your degrees are out of 360 because you have total, the total degrees in degree you can have is 360, right? So
118 degree.
Okay. So this gives that your relative frequency is 0.35, and you have to find what would this thing be. So this is 0.35 out of 1. So what would this thing be out of 360? So 0.35 out of 1. So out of 360, you should have, let's call it X. And I don't know how you guys do it, but this is direct, they're directly proportional, right? I do it by that style. So this will be X equals to 360 times 0.35. So you can check this thing. This is 126 degrees.
126.
Is this fine?
Can you explain again?
Okay. As I mentioned, I do it by directly proportional things that I've studied. But this is, so if for 1 you have 0.35, let's say, then out of 360, okay, just 1 second. You have 0.35 out of 1, right? So how do you convert this to percentage? If you have 0.35 out of 1, that means this is one whole. Out of that one whole thing, 0.35 is diabetes. Then how do you convert how do you find the percentage of this thing? This thing. 0.35 out of 1, I need to find the percentage. How do I do that?
Just multiply by 100.
Right. So if I have to find this thing out of 100, percentages, anything out of 100. So you multiply it with 100, that's it. That means, how should I write it? This should be the total, and this should be what's the share of what you're calculating the percentage of. So if you're calculating the percentage of this diabetes, then the share of diabetes is 0.35 out of 1. and you multiply it with 100, so you get the percentage, which gives you 35%. In a similar manner, if you have to find 0.35 out of 1, and then you have to find how much would okay, diabetes out of 1 is 0.35, so out of 360 it should be this. So the simple formula basically is, if you want the formula, if you want me to write down the formula, it's relative frequency divided by 1, or you don't need to write 1 because the sum of relative frequency into 360 degrees gives you, is it not in the summary or everything that you've discussed for week 2?
Yes, ma'am. Yeah, in class also, Usha ma'am told this.
Okay, this is relative frequency into 360 degrees. That gives you the share or the
Degree of slice.
degree share, degree of slice in the pie or in the pie chart. That means a circle is 360 degrees, and the share of Cancer then would be 0.35 into 360. How much is this? 126, right? So 126 degrees. So 126 degrees would be this from the center. This, let's assume this is the center of the circle, then 126 degrees share this thing. This is 126 degrees on the circle. This share would be of Cancer. That's how you construct pie chart, right? That's it. Do we have a doubt in this question?
No, ma'am.
Okay. This one's the next question. Give this one a try.
Pie chart.
Pie chart.
Okay. So a school administrator wants to compare the number of books borrowed from different sections of the library. That's what I said there when I said when you compare the shares, because there is a comparison between the shares who has taken. Yeah. Does anyone have a doubt? Okay. So when you're comparing the shares, because you are comparing the shares here, right? You are comparing the number of books borrowed from the library, and number of books are the shares. So let's say you have total number of books 100, and then 100 books were borrowed, and out of them, let's say 20 were of maths, then 20 were of science, 30 were of history, and then how much is this? 40, 70, and then the 30 were of social sciences. If this is the case, then you're comparing the number of books, because that's why you should have, or in other words, you're comparing the shares. That's why we have pie chart here.
Excuse me, ma'am.
Yes.
Ma'am, what does scatter plot means?
Scatter plot is when it looks like this. You will have it in later weeks.
Okay, ma'am.
This is not even done. Yeah, this is not even covered in the first 2 weeks. So this is when something's not covered, that's definitely not the answer. So this is not the answer, and then it should be pie chart. Yes.
Ma'am, it is comparing the number of books.
Okay,
So
yeah.
how
1 second. Yeah, this isn't. What did we discuss here? Here. We discussed this thing where we said when you're comparing the relative frequency, let's make this a simple rule so that we don't get confused. When you're comparing the relative frequencies, it's a pie chart. When you're comparing the frequencies, it's a bar chart. And when you're trying to arrange them, then it's a Pareto chart. Now let's come to the question again. This was the question. And we don't have relative frequencies mentioned there. And we don't have shared. Let's give this question a read. A school administrator wants to compare the number of books borrowed from different sections of the library. These are the sections. And then these are just the frequencies, right? These are frequencies for each subject: social sciences, history, science, and maths. These are the frequencies, and then you have to find the most appropriate graph. So pie chart is when you have to compare their shares, or if you don't get this thing, you can just see if they're comparing the relative frequencies, which we're not doing. We're just comparing the number of books. So when you compare the frequency, your number of books is the frequency. Number of books out of the total number of books, which is not even given here. This is frequency, and your relative frequency is number of books, or you can say frequency by total number of books. So when you're comparing relative frequency, you use pie chart, which we're not doing here, right? We're comparing the numbers, not the relative frequencies. So it should be bar chart then.
Yes, ma'am.
बस मैं पहले
Okay. This is a bar chart.
Hello, ma'am.
Yes.
My answer is the bar chart already say, not pie chart.
Ma'am, I have a doubt.
Yes.
Ma'am, for a highly skewed graph,
What?
what should I highly skewed graph?
Highly
In bar.
skewed graph.
Yes, ma'am.
Okay.
What should I prefer for calculation, like for
By
mode
highly
median?
skewed, you mean when it's shifted towards, when it's away from the center, right? When you have things
Yes, yes,
like this,
yes.
and it's either going towards this side or it's going too much towards this side. That's what you mean by highly skewed, right?
Yes, yes, ma'am.
Okay. Yeah, what about it? Let's say it's
What
this.
should I prefer for the given data? What should I prefer, median, mean, or mode?
Is it from week 2?
Yes, yes. We get two extra practice question.
Okay, let's take this extra practice question towards the end. Is that okay?
Yes.
Okay, ma'am.
Okay. Which situation is best represented using a pie chart?
Option C.
So now this is what you have for pie charts. Let's see. Number of visitors,
Option
whenever
C.
you have numbers, just numbers, it's always bar chart. So number of visitors to a website each day of the month, this usually will be bar chart. At least is more preferable than pie chart here. Okay, then we have comparison of students' test score across 5 subjects. So
Pareto's chart.
when you're comparing the scores of test scores across 5 subjects. So when you're these are against test scores compared, and I don't
It
think
can
pie
be bar
charts.
chart.
Okay, let's
Bar
come to
chart.
this one later. Let's come to the other two first, and then we'll come to this one. Percentage of the total market
Answer
share.
option C.
Pie chart.
Okay. Percentage of the total market share held by. So whenever you have things in percentage, or you can say whenever you have things out of something, out of 1, which is relative frequency, out of 100, which is percentage, or out of 360, which is degrees, that's a pie chart, right? All of these would correspond to a pie chart because you're comparing the percentage of the total market share held by 2 different companies. You're comparing the shares now. That's why this is a pie. The most appropriate here will be pie chart. Then growth of a plant measured every week for 2 months. So you're just measuring the plant's growth. Let's say if you're in centimeters, if you're measuring, then even then, if you'll make the things here, it will be, let's say here is the height, and then you say first its height was this, and then its height was this. It makes no sense for you to make a pie chart of this. What would we even do of the pie chart then? Because we don't even have frequencies here, we just have height here. That what was the height in the first week, then the second week. If you will make the bar chart as well, you will have heights here on this axis, and then the weeks here on x-axis.
Ma'am, growth can be in number.
Growth. This is growth of a plant. So this is one plant that you're measuring, and I don't see any other way of measuring. Okay. So this is a height. You will have height here as a variable, and then this varies here. So this only bar chart makes sense. Pie chart in this case does not even make sense. I don't know how we can make a pie chart here. So this is obviously you can't use the pie chart here. Let's come back to the second option. Comparison of students' test scores across 5 subjects. So let's say you have
It
test
is bar
scores.
chart.
Okay, let's say you have 5 subjects here. And then you're comparing, let's say if you're comparing how many have passed or how many, if you'll compare the test scores of students, you'll need, because on this axis, then you will be taking the number of students. Then also it will be what you can do here is, which is not in the second week, you can do 5 subjects here, and then here you can do it will need more than one bar, I guess. The multiple bar things that we have. The pie chart does not fit here either. Because there's no way I see you can make a bar chart, a pie chart for this one.
Okay, ma'am.
If someone can come up with some hypothesis, then maybe we can look into it. I don't see any way you can make a pie chart out of this information. Comparison of students' test scores across 5 subjects. And it's not even given how you're comparing them. Whether you're comparing how many failed in this subject and how many passed in this subject, then the bar chart would do. Number of students passed, and here you will have subjects. That would do. Then the bar chart would be the most appropriate one. But even if that's not given, pie chart makes no sense either way. Is that okay? Can we move to the
Then,
next
ma'am,
question?
shouldn't we use Pareto chart?
For the B one?
Yes.
Okay, if you're comparing the test scores of students, let's say across, how would you make the Pareto chart then? Because you're just comparing, you're not even saying how many have passed, how many have failed. You're saying we're comparing students. What way are we comparing? We don't even know that yet.
Oh, okay.
We can have subjects here, and then there are actually 3 things here. One is the subjects here. Then we have a number of students or something. And then we have the marks that they have gotten, right? Because we're comparing marks. So maybe we can have something like number of students who have gotten marks from 50 to 60. You'll have the number here, and then you'll have the subject too. So we have a lot of things here. That's what I see. Does anyone have a simpler way to approach this? Unless we assume something here for B option. We'll need to assume things. Otherwise, with just this information, we can't even say which one will be the most apt. And how will we make that chart? Is this okay?
Okay, ma'am.
Move to
Because you
next.
have 3 things here: subjects, then the number of students, because you're comparing the students' test scores, and you're not even given how many students' test scores are you comparing. So you have number of students, then you have subjects, and then you have test scores. So you basically have 3 variables here.
Can we make a bar chart for each subject?
Okay, let's make bar chart of each subject. We'll have 5 subjects here, and then what? What will you have on y-axis?
Maybe we can add all the marks
Number
of
of students.
Okay, number of students, and then what would this mean? We have already discussed this, right? Number of students, then you'll have to
And
eliminate one
x-axis
variable.
marks from like 0 to
Okay.
50, or
Then you'll have to make it different for every subject, right? If you say
yes,
number of
like one bar
marks,
chart for per subject, like
yeah, 20. That's what I said. You'll have to eliminate one variable. Now you've eliminated the subject variable, 20, 30, 40, and then so on this thing. Yeah, you can do that too. That's one possibility of a bar chart here, where you can have a bar chart of these are the number of students who have scored between 10 and 20. Then these are the number of students who have scored between.
Can we add the marks of subjects and then compare?
Yes, ma'am. Can we add all the like let's say
then
the
that is
students will
also
score,
eliminating subjects, no?
Yeah, that's what I
but
said. We have three variables here. We'll need more detail in order to know what actually is being asked in the question.
Okay,
Right?
ma'am.
Okay. This is the next question. Give this one a try.
We can only find mode.
Mode is 200.
What is the order here?
There is
Okay.
no order, so median
No,
can't.
order can be, there is
Yeah.
order, I think.
I think sometimes you're
Is
not explicitly given in the question the order. Sometimes the order is not explicitly mentioned, but it's
It is,
inherent,
can be
right?
ordered.
Yeah. So it can be ordered. You can order this in the given order. Laborers, then engineers, then supervisors who
Then
supervise these
director.
people, and then directors. We have an inherent order here. This might not even be given in the question that that's the order, but we know that there is an order, right? It's like this thing only when you have in this we'll only have two things. When you have a school where you have teachers and then you have a principal, the order is inherent there, right? So similarly, we have an inherent order here. Let's think of one more example when we have an inherent order which needs not to be mentioned.
Employee, HR, and then
Yeah.
CEO.
Yeah, in companies too, when you have something, this person working under this person, then this person working under this person, then you have the one who supervises all of these people, then you have someone else. There's you that won't be given in questions, but we know that there's an order, right?
Hierarchy.
Yeah. So we have an order here. So we can find both of these things. So for the
Yes,
mod
ma'am.
thing,
Both mean and
yeah,
mode and median
Labor.
is laborer.
yeah, they're both meaningful. Yes.
median and mode both are levers.
Okay, let's see. Mode is like you don't have to do anything. You just have to see the most number of who has the most frequency. And if you have, you can see the most number of people are here in laborers. So that's why this will be the mode. Mode is this. Mode is basically who appears the most number of times. So laborers in this list appear the most number of times. That's why that's the mode. So your mode is laborers.
Excuse me,
And then we
ma'am.
have the median. Yes.
Yeah, actually, due to rain, the voice got disconnected. Can you please once again explain the question?
So we have this question where we have a company consisting of 200 laborers, 50 engineers, 10 supervisors, and 2 directors. And you have been asked to find median and mode. So mode is something which is very simple. You can just look at this and tell which of this appears the most number of times. So laborers appear the most because the frequency of labor is the most, right? There are 200 of them. That's why that's the mode. So the mode for this data will be, even if you write that, you will have laborers. We don't even care how the data is arranged for mode, right?
Yeah.
The arrangement does not matter for the mode part. So this will be your mode for this data will be laborers. Then the median thing, you will have 200 laborers plus 50 engineers plus 10 supervisors plus this 2. So this is 250, 260, and 262.
262.
Right?
262.
And then you have to find the middle of this. And this is an even number. So you'll have 262 by 2 and 262 by 2 plus 1, which is 131.
131 and 132 between.
And 132nd, right? It's two observations.
Both the line, the 200 between.
Will be median. So what you do for median is you arrange these things, labor, 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 200 number of times. Then you will have engineer, engineer. This is what you do, right? But you cannot do such thing for such a large data. This is 50 number of times. And then you have 10 supervisors. And then 2 directors. And you have to find the 131st and 132nd entry. And we have arranged them in the, this is arranged in a ascending order, right? You can arrange it in descending order, does not matter. So we have arranged this in ascending order. And then you have to find the 131st. So first arrange the data in ascending order or descending order, and then find the middle entry, which is the 131st entry and 132nd entry. So these are 200. And the engineers are, so your 131st and 132nd entry is going to lie here only, right? You don't even have to go beyond this. 131st entry will be here. 131st entry will be here. This is first, second, third. It keeps going on. This is the 200th entry. 131st is somewhere here, which is a laborer entry. And that 132nd is also a laborer entry. Is that okay?
Yes.
So the median and yes.
I have a doubt.
Yes.
Ma'am, in the practice set, there is a in the practice set, there is a similar question, like they have asked us to find the mode and median, but the information is given like the role or position of the team members, like goalkeeper, defender, midfielder. So the answer is median cannot be found.
Okay,
So I have a
goal,
doubt.
defender, and all, they don't have orders, right? There's no hierarchy here. What do you think? How will you arrange these goal, defenders, and all? The goalkeeper, the defender, how do you arrange them? How do you decide which should come first and which should come later?
Means if
Do we have an
designation is given, then we order them.
There
Number
is
of
no
players,
designation.
number of person.
Okay. This case is entirely different from what we have here. That supervisors are supposed to supervise everyone, right? They're supposed to supervise the engineers. That's why I said there's something called inherent order, which you, like one of the examples was given by one student here. What was it? Where you had a company and all. So when you work in company, there is an order there, right? You can't say
It
everyone
means
is.
that when designation is given, then we can find the order.
You can't. Designation should have a meaning. The CEO holds the highest position in the hierarchy. We know that. But who holds the highest position here?
Okay, ma'am. Understood.
Right? The directors hold the highest position in this hierarchy, we know, in this one. But we don't know about the goalkeeper and defenders and all, right? We can't say the same
Excuse
about
me,
them. Yes.
I have a doubt.
Yes.
In the ascending order, it is a rightly skewed graph, I think.
What?
In the previous question,
Yes.
it is positively skewed graph in increasing order.
Okay, if you'll construct if you'll make the bar graph, you'll have 200 frequency here. But why are we discussing this? Because it's not the rightly skewed, leftly skewed. All these things are not here in the syllabus. But okay, let's see this. You will have 200 here. Then the next one is 50 something. It's here. Then you will have what is it? The next one's just 10, and then we only have 2. So we can say that this is skewed towards the right, the left end. That's fine. But do we have these things here in your syllabus for week 2?
Yes, ma'am.
We have the skewed thing here. Okay. So we'll see. You said there's one practice question, right? We'll see this. We'll see this when we're done with these questions. There are very few left anyway. So this is the next question. This is again something similar to what we've done. You have this table. You have to fill in these gaps. Okay. We don't have a gap here. We have gaps here. And here. And then we have the degrees here. This is one extra column here. And okay, so this is one thing that's given here is 108. So if this column were not given to you, if this were missing, then you would not be able to find. Okay, we have two things
Total
here,
is
right?
20.
Okay, that's also fine. You can find from here too. I thought we don't have two values in the same row. Okay.
Milk frequency is the 6. Relative frequency is the 3.3. And bread is frequency 3. And vegetable frequency is 5. And fruit
Okay.
is
Let's
2.
do one thing. Anyone who finds the answer can drop their answer in the chat box, right? That's just much easier. Just drop your
Okay.
answers in
Okay.
the chat box. Okay. So first we have this 108. Let's start from this one only. Or you can start from here because out of you have 360 out of 108 out of 360. So out of 1 you will have this.
Yes, ma'am.
Right?
Please let us solve first.
So this will be, I don't know how much is this. We'll have to calculate this. This is it's
0.3.
okay. This is 0.3. So this is going to be 0.3. If anyone has a doubt in the formulas that we're using here, although I've already written the formulas, for you to find the relative frequency in terms of, we already know that your relative frequency when multiplied with 360 gives you the degree in your degree, right? Or using the same formula you can use, just 1 second. Using the same exact formula, you can try to find the relative frequency when degree is given, right? So you can find degree when relative frequency is given or relative frequency when degree is given. Just give me a second.
Ma'am, relative frequency into degree is equals to what, ma'am? Oh, 360.
Yeah, it's
Got it.
relative frequency. Okay. My pen tab's not working. Just give me a minute.
Ma'am, close the tab again open.
It's just 1 second.
It's work, ma'am. Just close the tab once. Not working anything. Ma'am, close the tab and again open the. Hello.
I don't think that the problem is with the pin. This just 1 second.
Just one time close the share screen, again open. Already fixed it.
No, the sharing screen's fine. That's not troubling me.
Okay.
This other thing's troubling me. 1 second.
Oh, just close one time a window, again open this. All thing working. Everything is stop here, not working, not clickable. Everything black is white.
Yeah. Okay. So we have this here. What were we doing? We found this to be 0.3. Then we need this thing, right? Okay, let's first find this. You have 0.3 relative frequency, and the formula that we have is, oh God.
Ma'am, please one time you close the windows and again open all thing is working. One time,
So
ma'am.
that's
All the working, working.
this is not the laptop issue. This is the the cable issue. That doesn't fit well. It keeps getting disconnected. That's the issue. Closing anything wouldn't help.
Okay, ma'am.
Okay, let's do this thing. So we have 0.3 here, and then this sum is 0.3, 0.2. This should sum to 1. And we have 0.1, 0.2, 0.3, and then this is
0.25, ma'am.
0.3. Right,
The gap on it.
0.6, 0.75. So this will be 0. To find this, you will do, this is 1 minus 0.75. The total
Yes,
of these, right? So this will be 0.25.
yes,
Done
ma'am.
with the relative frequency part. Then we can find the degrees for this, right?
Yes, ma'am.
Degrees can be found
Yes,
out.
ma'am.
So
Second,
this is
second is 5.4.
for that you'll need 0.15 into 360 for the second one. Then you will have 0.2 into 360. You just have to multiply these things with 360 to get this.
Yes, ma'am. Yes, ma'am.
So this will give you, the 0.151 will give you
54.
right? This will be 54.
30 is 72.
Yeah. This will be this 0.2 times this. So this is 72.
Fourth is
This,
90.
yeah. And the
Last
last
is
one is
36.
90, and this is the easiest one, 36.
36. Yeah,
And this will sum up to 360.
360.
And then we are just left with this. So for you have frequency divided by the total number, this
Total
total,
number
let's
of
call it
frequency.
T.
Total
This
number.
should be 0.2, right?
Total number is 20.
Okay.
Yes.
So this T, this is going to give you 4 by 0.2, which is 20. So this total is 20.
Yes, ma'am.
Then
Ma'am,
you can
why
find the
0.2?
remaining ones, right? The remaining ones will be, for this one, the first one, you will have, let's call it X. X by 20 should be equal to 0.3. So this will give you 6. And similarly, the bread one will give you, so you have a simple
3.
formula now, which is you just have to multiply these things with 20, right? That's what your formula becomes. X equals to 0.3 times 20. So just multiply the relative frequency with the total number. You will have these values.
Ma'am, where did you get that 0.2 from? 4 by total is equal to 0.2. The first
This
one you did.
one
No,
or
above.
this one?
Yes, ma'am.
From
That is
here,
the formula.
it's frequency by sum of frequencies.
Total number of frequencies.
Yeah, total number or sum of
Is
all
equals to
frequencies.
relative
Yes, ma'am.
frequency.
All is equal.
This is relative frequency. Okay. So for you to find
Yes.
frequency, you just have to multiply relative frequency with the sum of frequencies, which is T. T is 20. Just multiply the relative frequencies with 20. You'll multiply this thing with 20. This is what you'll get.
Yes.
So
Yes,
this
save the
will be 3. This will be 25 times 0.25 times 20. This is 5. And this is 2.
2.
2.
Total is 20.
Yeah. So this is it. Same way you can be given percentage here. That can also happen. And everything remains same. Okay, can we move to the next question if this one's done?
Yes. Yes, ma'am.
Yes, ma'am.
This is the next question. So again, you have to do things. You have to find percentages and degrees. The graph's visible, right?
Yes.
This is it. Let's first find, because this is your y-axis is percentage of students only. So you can find the percentages from here, which isn't very clear, by the way. This is somewhere between, this looks 8 to me. I know we should have had a marking here because it gets confusing, but it looks slightly above the middle. So that's why it's 8. Then this is 10. The other ones are clear, right? This is clearly 10, clearly 15. This one again, this looks slightly below the midpoint of these two lines. So it should be 12. Then this one is 10 again. And then this one is 25. The other one's 20. Total is obviously 100. And then you just have to find the degree. So degree is 8 by 100
It's called
times 360, right? This is out of 1. When you do 8 by 100, you'll get the relative frequency. If you want to find relative frequency, it will be 8 by 100. So this 8 by 100 thing will be out of 1. That's relative frequency. If you want it out of 360, multiply it with 360. If you want it out of n, multiply
28.8.
it with n. That's it. So the first thing will be, you just have to multiply these things. That's it. This is
28.8.
8
28.8.
by 100 into 360. It's 28.8. Then this is 10 by 100, which is 1 by 10 into 360. So it's clearly
36.
36.
36.
And this is 15 by 100 times 360. So this is 3,
54.
2, and
50,
18. 18. Okay,
54. 54.
this is 54. This will be 12 by 100 and 360.
360. 43.2. 43.2. Right.
You can do the other ones, right? They are the same.
Yes,
Or
ma'am.
do we need to do those here? This is just use this formula. Percentage, let me call this P. So you will have P by 100. And let's call this D. So your D will be equal to P by 100 times 360. That's it. This is the formula used here. And you have to use the same formula for each of these. That's it. And then we have,
Yes, ma'am.
we had a few more questions, but we had doubts too, right? So let's take them up first. Yeah. Some people had doubts in a few questions.
And the question in
Yeah. Which question?
I'm telling that the question sessions end here.
What?
Ma'am, you are done with this question, all the questions.
Yeah, we're done with the questions. I have a few more, maybe one or two more questions, but some people had some doubts in the previous graded assignment and the practice assignment somewhere. So
No,
we're
I have a doubt
taking
in
them up.
extra practice assignment.
And in the chat about the 8 and 12 thing, I know this is how you find this thing is when you have this. If you look at this thing carefully, which you can when you this. The middle of these two lines is somewhat below this bar, right? So you wouldn't be expected to write 8.7. Those are going to be natural numbers only. It will either be 7 or 8. And because it looks closer to this above line, this bar looks closer to the above line than to the below line. The 5% line, it's closer to the 10% line. That's why I've taken 8%. That's it. And similarly for this one, because this one looks slightly below the middle of these two lines, 10 and 15. That's why it's either 12 or 13, right? Between 10 and 15, because it looks closer to the middle. So it's either 12 or 13. It's definitely not the middle. We can see that. So that's why we've chosen 12, because it looks closer to the 10 line than it is to this 15 line. Yeah. Let's come to the doubt thing.
Hello, ma'am.
Yes.
The extra practice assignment.
Okay, I'll have to download it. Give me a minute. Week 2 or week 1?
Week 2, week 2.
Okay. Which question? Which question is it?
Telling this. Question number 5 and 20. Doubt between these two. That's kind of similar.
5 and 20.
Yes, ma'am.
Okay. Let's do the fifth one first. Let's see the fifth one first. A frequency distribution of number of clicks per user is found to be positively skewed, right skewed. This is not discussed in the video lectures by the prof, right?
Yes, I think, but in the practice assignment, they quick to they given so.
Okay. Is found to be positively skewed. Which of the following relationships is most likely to be true? Number of clicks per user. So if it's rightly skewed, your graph it looks like this. Let's assume it look rightly skewed one will look like this. So let's say this is it. So for the mode thing, what do you do for the mode thing? You see which one is the most,
The highest.
which one occurs the most, right? So this one will occur the most, right? So your
Yes.
mode it has to be it's right skewed, right? And right skewed means this. So your mode should be the greatest one, right?
Right, ma'am. Greatest one. Most
Whether it's left or right, modes will be the same, right?
No, mode is the highest. If this is the frequency, then it's the highest frequency one. And if this is how your graph looks like, and if it's left skewed, it will look like this. Then your mode will be this one, the first one. So it will be the least one then.
Ma'am, positively skewed means the values on the left are higher than on the right, right?
So if that's what it means, then mode should be the least one, which looks in alignment with the answer given. So I think that's the case. If this positively skewed should mean this thing, then you can look up what it means.
Yes, the internet says that right skewed or positively skewed means the values on the right side are lower and the ones on
Okay.
the left side are higher.
So if this is right skewed, then this is the mode here. So mode should be the least. Then coming to the other ones, the median is comparison between, okay, let's first compare median and mode. So median is what appears, what's in the middle, right? If you'll arrange them in the ascending order, which it already is arranged in, or in the descending, this one's arranged in the descending order, then the middle value gives you the median. So it should be somewhere, if this is where it starts from, the median should be in the middle, right?
Yes.
So this should be median. And then we have the comparison between median and mean. So for the mean part, mean is the average, right? Where you
Yes.
take all the, okay. So let's take a rigid example so that things get easy. So this is the frequency, and let's take these to be the number of assignments students have done. So this is one number of assignment, two number of assignments, and three and four number of assignments. Then your mean will be this is, and for you to find mean, you need 1 multiplied with the frequency, right? You have 1 repeated. It's 1, 1, 1, this number of times. Let's say this is Let's make it more restrictive. Let's call this 30, this one 20, this height 20, this height 30, this height 10, this height 5. So this will be one repeated 30 number of times. Then two repeated 20 number of times. And also you can just add these things, right? So one will be added 20 number of times. Sorry, 30 number of times. Then 2 will be added 20 number of times, which will give you 40. 3 will be added 10 number of times, which will give you 30. This will again be 40. So this will be, and then you have the total, right? So, and the total is 30, 50, 60, and 65. Although this is not the right way to do things because you can't take a particular example, but let's see what works here. Because if there's one rigid answer to this, if there's one rigid order to this, then this data should follow that order, right? The data that we have taken. So this will be 30, 40, 70, 100, 140, and this is 65. What is this? This is greater than 2, right? So, oh wait. 7, this is less than somewhere between 1.5 and 2. What's the exact value? 140.
It is
Okay,
greater
this is
than
greater than 2.
2.
It's 2.15. That's the exact value. And the median that we'll have for this one is, median is the middle observation, right? The middle observation will be the total number of 65 observations. The middle one will be 66, 33, 33rd observation. 30 are here, and then you'll have the 33rd observation here, which is 2. So that means this 2.15, which is your mean, is greater than the median in this case. And if we have a rigid formula, if we have either median less than mean or for right skewed, if you have two options, let's say you have right skewed, you have been given two options. For right skewed, either median is less than mean or mean is less than median. If these two options are given to you, then every data should satisfy these two options, either of these two options, right? So this data that we took is satisfying this one. That's why this one should be correct. Is that okay?
Can you repeat the mean calculation part one time?
Okay. You have, this is the number of assignments that we have. We have one number of assignment. We are trying to find the average number of assignments, right? So 30 students have submitted one assignment. So we'll have 30 here. 20 students have submitted two assignments. So we'll have 40 number of assignments from here, then 30 number of assignments from here, 40 from here, right? And then how do we find that's how you do it, right? The frequency times this thing, and then you take the sum of that, and then you divide by the total number of frequency, right? That's how you find the mean.
Yes, ma'am.
This should
Yes,
be
got it.
65, and this is what you get here. If you've been asked, but be careful for proving things, you need something rigid. If you were asked, if the question was framed like this, is it true that mod is less than median? If this were a true and false question, and you were asked that, is this true? Is this thing true for right skewed kind of data? Then you'll have to have something rigid. You cannot rely on an example, which we did this time, right?
Yes.
Okay, that's it. This one's done. That's why this one's correct. Do we have anything else?
Ma'am,
Yes,
question number 20.
Okay, I'm sorry.
20. Okay.
Ma'am, also 14.
Okay. So this 14th one is which of the following measures are robust to extreme values? We'll just give me a minute. Okay. So the question is about there are two words used here. One is extreme values, the other one is robust, right? Your extreme values means, let's say your data is somewhere, let's say you have 15, 16, 17, 18, 13, and then suddenly you have something as 90. Then this is called something extreme, right? Because your rest of the data is very far from this value. They are comparatively closer to each other, but this is just too extreme. That's why this is called an extreme value. That's one thing that's used here. And the other thing that's used is robust. Robust is basically how much is your data less likely to change, right? Which tendency is least likely to change. There are tendencies given here, and you've been asked which one of these is going to change or is least likely to change, right? So let's see which one is least likely to change. If you look at this data, just this data, and then if I'll add 90 to this data, then do you think that the range is changing too? Robust means your tendency, a tendency is called robust if it does not change much,
Yes.
right? So do you think your range is going, if you add 90, an extreme value to this data, then the
Yes,
range will
change.
also
It
get
will change.
extreme, right? So this is
Yes.
not one of those robust tendencies. Then we have mode. Let's talk about mode then. Let's talk about the ones that are not robust. This a mean is also not robust. Now let's say you have 13. If you this is obvious, right? If you have 13, 15, 17, 16, 17, and 18, if you have something like this, then the mean is going to be somewhere near these quantities only. But now if I'll add 90 to it, this basically means we can also check this thing. If you add these things and then you will divide this by 5, this is going to be too far. This is going to change a lot if you will do this. 13, 15, 16, 17, 18. Then you have 90. And then you do 6. Because this quantity has changed very little, but your numerator has changed a lot, right? If you want to check, you can find these values. You see a very large difference. There's going to be a noticeable difference between these two. They're not close to each other, right? So if you will do these things, that's why your mean is also not one of those robust things, because it also changes if you change the values a lot. If you take extreme values, mean will also increase a lot or decrease a lot, depending on what you've done with the value. Is that okay?
Yes, ma'am.
That's why mean and range are incorrect. Now let's come to median and mode. Mode is basically, now because mode is basically which is repeated the most number of times, and here every observation is just
Highest
one time.
frequency.
So that makes no sense here. But if I'll increase the frequencies here, let's say I have 13 3 times, 15 7 times, 16 9 times, then 18, 20 times, then we know that the mode of this data is 18. Now, if I'll add some frequency here, if I'll add extreme values here, unless I do this, then I'll add 90 and I'll add not just 90. Now, I'm not adding one observation here. I at least have to add 21 observations, right? I'll have to add significant number of observations to change this data. One extreme value is not going to change anything, right? Are you following?
Yes, yes.
Two people have raised hands. You can unmute yourself and ask if there's something.
Yes, ma'am. I had a question with
Yes.
the graded assignment, week 1.
Week 1 graded. We'll
The
do this
first week.
after this question.
Sure, ma'am.
This
I can
one.
wait.
Okay. So you'll one, yes.
I mean, I had out in week 3, the percentile portion I have not understood. So will it
Week
be solved
3.
by today or tomorrow?
Week 3 will be done when week 3 summary will be discussed.
Okay. So not today,
Okay.
no?
No, not today.
Okay, okay.
Ma'am,
Okay.
will you take the 20 number question? Number 20.
This one?
Yes, yes.
Okay. We'll take this too. Let's do this one first. So you got the point, right? Mode does not change
Yes.
as much. If you only add 90, it's not going to change at all. Unless every observation was like this one. If you have every observation one, then basically all of them are, if this is the data, all of them are modes, right? 13 is also a mode, 15 is also a mode, all of them are modes. And then if you add 90, that will also become a mode, right? So
Yes, ma'am.
this is not going to be something extreme. Your mode is not going to change extremely. You're getting the point, right?
Yes.
This is not something that it will eliminate others and then 90 will become the mod now. That's very less likely to happen, right? Unless you add a lot of 90s here or you add two 90s here. Now this can become the mod. That's why in that sense, it's considered robust. And then coming to the median one, median
But
is,
hello,
yeah,
ma'am.
yes.
But then mode can be affected if I increase the number of outlets.
That's, you're making it too extreme, right? You're not just adding one extreme value, you're adding too many, basically more than 20 number of values. That's when it's likely to happen. Mode is anyway, if you don't do something extreme in the sense, if you're not adding 21 values, 21 number of times, then your mode's not changing. You will have to add it 21 number of times.
Okay.
Okay. And then the other one is median, right? So for your median part, this adding 90, 21 number of times is something we don't usually consider. Even though that's not mentioned, that you can't add an extreme value more number of times than to what was the mode initially. You cannot add it 20. That's not given in the question, but still. Okay. Then the median part, for the median one, it's median is the middle observation, right? So if you'll
Yes,
arrange
the
these
median,
things,
I
this
got it.
one's
I think
okay. This one's
the
just
middle
easy.
value it's not
Yeah.
affected by.
It anyway won't be, if you add an extreme value, it itself means that it's something very away, very far away from the data. So it won't be in the middle. You can't add something here, right?
Yes, ma'am.
And even if you add something here, it won't be a great change. Okay. So then coming to this one. You should prefer median over mean when data has extreme outliers. Okay.
Yes, it is true. I think
Coming to, just 1 second, sorry. Yeah. So in this one, you should prefer me. We have just seen
Ma'am,
Mean is
for
not likely
preferring
to,
means, ma'am,
preferring
excuse me, ma'am,
means, yes.
to calculating the data.
Let's say you have to, median and mean, basically they are descriptive measures, right? So it's basically to summarize your data. So if you have to summarize the entire thing, it's like what should you prefer? Should you prefer mean or should you prefer median? If you have extreme outliers. So we've just seen if you have extreme values, your
It is
mean is yeah, the
median
robust
should be
thing.
preferred.
Yeah, you should prefer something which is robust, which is not going to change a lot, right? So median should be preferred over mean when you have an extreme outlier. We have just seen it in this question. Then we have data is highly skewed. So data highly skewed means this one. We have seen highly skewed data, right? So if you have highly skewed data,
Ma'am, difference
let's see a
between
highly skewed data.
this is positively skewed and highly skewed mean this is dense or something.
No, highly skewed data should be this thing only, where you have a lot of changes here. It's either decreasing rapidly or increasing rapidly. That's what it should mean, I believe. So for a this is your rightly skewed data, left skewed data, those all come under highly skewed. Highly skewed as in this would be less skewed. And if you'll take some drastic changes here, that will be more skewed, right?
I think
That's the
the
difference.
slope is
Yeah,
higher.
kind of. So data is highly skewed. If you have highly skewed data, what's the median here? The mean would be, we've seen this thing here, right? So if you have a highly skewed data, the mean will be, what's happening here is these are frequencies, right? So when you
Yes.
have something like this, when you have extreme frequencies and then they keep decreasing rapidly or increasing rapidly, then you will have, let's say, this is again 1, 2, 3, 4. Let's take the easy things. And then the frequencies are less, let's say 100, then it's suddenly 50, let's say 1000, then 500, and then it's 100, just 100, and then 50, and then just 10. If that's what's happening, if this is one data, this is highly skewed. Then if you will consider the median over the median would be, let's find out the median and all first, right? The median would be, this is 1000. Okay. Your median would anyway just be the first one, right? If it's highly skewed, then there are good chances that your median will lie somewhere here on this
Then
side.
mean should be great option to prefer.
Why do
For
we
this
actually,
case.
why we find median and mean is therefore the central tendencies things, right? Like what's central to this thing. So if you will have median, it's more likely to be, how should I explain this thing? This is, if you have a highly skewed data, there are good chances that the central thing that your central this thing number would be somewhere between these only, right? This is most likely to be somewhere here only, which would not be the good representative of the data that you have. If you have 100 number of times, it wouldn't be a good representative, right? This is 100 number of times, sorry, 1000 number of times, then 500 number of times. Median just does not look like right because it's repeated a lot of times. Okay, I'm not sure about this one. I'm not sure about the B option. Even not more sure about explaining it.
Yes,
So
mean can be preferred in B option, I think. I am confused in B option also.
okay.
Mean is
So
calculating the total value. So, but if the median is preferably in left side, so it can't represent the graph properly, I think.
Yeah. Act
So, for example, if the data
that way
is,
it can go.
for example, if
Yeah.
the data is positively skewed, that is, most of the values are on the left, then the median would be to the left and the mean would be to the right, which means the mean would be a worse representative of the fact that most values are on the left. Am I on the right track?
Yeah. What did you say?
So I said, like, if you draw, for example, a normal distribution, but it was skewed to the left, that is like positively skewed, like
Okay,
in a
this
like
thing you're trying to say, right?
yeah, like the opposite. So like if most of the values were to the left,
If it works for the opposite, it should work for this one as well. That's
yeah.
okay.
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 So
Yeah.
let's say most of the values in this case are on the right.
Okay.
So the mean would be a bit to the left and the median would be a bit to the right because of what the other question said, right?
We are
Which
saying
means
the mean would be somewhere
uh,
here.
yeah, on the left side because now your data is like skewed to the right side. So like more data on the right, less on the left, right?
So if you mean it, it should be not properly
The
left.
mean would be somewhere here only, I believe,
Okay.
because it's
Okay, but then this doesn't look like a skewed graph to me.
this. That's what a skewed graph. If you're talk, that's what a skewed graph is. It's something here. A normal distribution skewed is this only, right?
Okay, yes. Now a lot of the values are on the right. Now, if the mean would be somewhere to the left of the peak, but the median would be a little closer to the peak. So like this is a
Somewhere to the
mode.
left.
Yeah. So like if
This
this
is the
thing
peak.
this mark is your mode, then a
Hmm.
little bit left to that would be the median, and yes, a
Okay,
little bit
you're
left.
doing this.
Yeah,
One
yeah.
second.
I'm taking the logic from that other question.
Okay, all right. Okay, okay. Got it. You're
Yeah.
using
This
this logic. All
so
right.
so the median would be a bit to the left, and the mean would be even further to the left.
Okay, the order here is
Yes.
mode, median, and then mean.
Yeah, but in this case, opposite because our graph is skewed the other way.
Okay, so
So then mode is on the right, the median is to its left, and the mean is even further to the left.
this is the mode.
Yeah.
This is the median, and
Mhm.
yeah, it lies in the middle
Yeah.
of
So
these two things.
so
Okay.
this would theoretically mean that the median is doing a better job of describing how the graph is skewed compared to the mean, right? So yeah, if this is a mean,
Not median
wait,
wouldn't be here actually,
yeah,
but
yeah, this,
okay. It'll
okay,
somewhat be here.
yeah. But in this case, I would argue that yeah, the median is doing a better job of showing that the data is skewed than the mean. Does that make
Okay,
sense?
but it does make sense, but it's only about this only tells you about you're saying the median does a better job at describing the skewed nature of the graph,
Yes,
right? But
yes,
there are a lot of other things too to the graph, I
that's
believe.
true.
So that
And this is a generalized statement, so we can only in example. This is only for one example. I think.
yeah, and this is very particular too.
I think this would generalize to any skewed graph because like any skewed example you take, the
Yeah,
median would be like closer to the peak,
yeah, we have
and the
in
mean
in
would
the
be further
question we
away.
have a skewed graph. Okay, this is
Yes.
we have a particular case here of skewed graphs. So okay, if we go by this order, it makes sense why mean
But
would be the least
ma'am,
one.
I have a
Yeah,
doubt in this. The median is representing the mode towards the mode, and it is the data is representing the mode portion only, but the mean is collect of the low frequency and high frequency, and it is a mean, so it is representing all the data, I think, the mean of the data, so it is a correct representation.
Okay, let's see. I'm not, that's why I said I'm not sure about this option. We can take this option, this question in the next class. So then we have the third option, which is data is categorical. Then categorical is the qualitative type, right?
Yes, so
So
mean cannot be. So
yeah,
option
and
C
then
is
mean does not make sense there, right? So you'd obviously prefer median, and then you want to include every data value in the calculation. So if you want to include every data value in the calculation,
it
then you
doesn't make.
should, mean is actually better at representing the entire thing. Like if you want every data added to it to make sense and to affect the data, then you should prefer mean, right?
Yes.
That's why in such cases, when you want every data, every observation to contribute to your answer, then it should be mean, because adding a data changes the mean and it doesn't actually change the median much. That's what we've discussed here. So this one also is incorrect.
Ma'am, I had a question here.
Yeah.
In the C option, when you said the data is categorical, it doesn't make sense to use the mean. But
Yeah.
if it's categorical, the values, the categories cannot be compared, which means we can't even use the median here. The only thing we can use is the mode, right? So that would
No,
mean
ordinal is a
both were
But
categorical
in
in
bad
the
numbers.
other, one
Ordinal
second, in
is
the,
also under
yeah,
category.
we have seen questions where we have categorical data and we've found the median for it, right? Median and mode both.
Okay, so like we're talking ordinal stuff,
Yeah.
right?
Ordinal comes under
Okay, makes sense.
categorical, right?
Yes,
Yeah.
but in that case, if we are actually using median and if mean is a worse, is a less reliable option,
Mm-hmm.
then C should be part of the answer, but it isn't. Because the question asks
Okay.
when would you prefer the median, but here we are preferring the
Okay,
median
maybe
and
this
also
other,
simultaneously saying C is wrong.
yeah. So maybe the way they've put this is that you can't even find mean, so there it does not make sense for you to compare these two, right?
Yeah,
So
this would
you
make
can't
sense if the
compare
data is
here.
nominal. Yeah,
You can't say we prefer this over this, because both of them are not applicable to that kind of data.
that's fair. Yes,
So by that logic, this should not be correct.
makes sense. Thank you.
Okay. So does anyone have anything else?
Yes,
Ma'am, I
I
have a
still have that
doubt
question
in
about the
2.2
graded assignment.
practice assignment.
It's already 23 minutes past the actual time. Let's take one more question and then we'll end it here. Yeah.
Can I please ask?
Ma'am, practice assignment 2.2.
Okay.
Uh,
I think this question, practice assignment 2.2.
Ma'am, question number 4, 6, and 7. In just the same question, like part of the same question.
Okay, 1 second. For what?
Ma'am, in that, like the option number D, that is about the, like if we consider
Okay.
S as the jersey in
So
that
you have
number.
doubt in all the fourth, fifth, and sixth question, is it?
Yes, ma'am, like the main is in the fourth, only the D part. Like why it is correct.
The fourth question, right?
Yes, ma'am.
Okay. So this is the question. And your doubt is, why is the D part correct?
Yes, ma'am.
Okay. Let's give this question a read first. You have a contract for sports jersey, 45 players, and all the players except two gave the preferred sizes as these, and then A, B do not know their sizes. So if player A knows that most of the players have a similar physique to him with jersey, can he order? So, and you are doubtful about this option. So can he order size M if it is the median of the size of jerseys? So if it's the median of the size of jerseys, then we know that most of the players have a similar physique, right? That means his physique, he should prefer what most of them are preferring, right? So if
Yes,
you'll
ma'am.
arrange, and that means there is a clear majority there, right?
Yes, ma'am. So,
By that
according to
means,
that, the mode would be
yeah.
the correct answers, right?
No, we're just looking at these options. The mode one's fine. I think these two options are already correct,
Yes, ma'am.
right? So these two are already correct, and you're doubtful about this option. Then can we choose this one or not? That's your doubt, right?
Yes, ma'am. Like in the when I didn't take it because I didn't feel that it is right. Like how did we
Okay.
consider it correct? That I'm not able to understand.
Because it says most of the players, when you say most of the players, it's at least more than 50%, right? How do you conclude that this thing is, when you say that most of the players, let's say you have 100 players and you're saying most of them prefer something, that means at least more than 50 prefer something, right?
Yes, ma'am.
So that means more than 50% of the people prefer small size jerseys. That's their size, let's say. So if you have small size 50 number of times, and that's how you arrange it, right? First you have, let's start from the small one only. First, small ones first, then medium, then large, and then XL, right?
Excel.
So you will have S more than 50. If you have 100 observations, you will have S more than 50 number of times, right? And your median is 50th entry and 51st entry, right?
Yes, ma'am.
So if it's more than 50, then we're taking at least 50, it will be at least till 51, right? Because it says most of the players. So it will at least be, if there are 100 players and 50, it will actually, if it says most number of players, then at least 51 players should prefer it, right? That's
Yes,
what
ma'am.
most
At
of
least,
means.
yeah.
That means till 51st entry, you have small size. And then after 51st entry, you will have medium, large, and whatever's after that. So 50th and 51st entry will be small size. That works, right?
Okay, that's why it is being D part. Okay.
Yeah.
And for the like the reason behind not choosing the C part is that because we have been the S is the smallest, and for the median we need ascending to descending order. So most of them will be occupied in the S only, and M would not be remaining, right? That's why it has
Yeah.
not been chosen here.
Because of most of the players being in the small size, preferring the small size. You wouldn't
Okay,
come
ma'am.
till the medium part.
Okay, ma'am.
Okay.
And just I need to just ask one thing in the fifth question.
Yeah.
Like in the first part is first A option is written that mode does not change. So it is written in what perspective, like the value or the size, or it's that way.
Fifth is the 43 chosen jersey sizes are arranged in the increasing order of sizes. If player B knows what his size, jersey size is approximately equal to the jersey size of the players of the 22nd ranked jersey, which jersey size should player B order? So, and we have, so it's, okay, what does it say? It says there are 43, the size of 43 of them is known. B is going to choose something and he knows that his size matches with the 22nd person, right? And 22nd is the median for this data, right? So if M is the median, then he should prefer M. If S is the median, then he should prefer S, right? Is that okay? Is it okay to whoever had a doubt in this fifth question? Okay, I don't think she's here.
Ma'am, am I audible?
Yeah,
By mistake, it got disconnected.
that's
Just
okay. So this person B, his size matches with the 22nd person. So if 22nd is basically, if you have 43 entries, then 22nd is going to be the median, right? So that means if M is the median, then he should prefer M. If S is the median, he should prefer S. Is that okay? That's why these two options, M and S. If M is the median, I think the options remain same in the fifth one, but these two become correct there in the fifth one.
Yes, ma'am.
Okay.
Thank you, ma'am.
Yeah. Okay.
Can we please discuss my question?
Yeah.
Week 1 graded assignment 1, question 1, the very first.
We discussed this question, right? In the
Uh,
beginning.
I don't know if we did. I actually joined like 15 minutes late because my
Okay.
internet was off.
Week 1 graded assignment first question, right?
Yes, it was a
And it
multiple
says,
choice.
okay, and it says all the options are correct, which are
Yes.
not.
Yeah,
Not
yeah.
all of them are not
Okay.
correct. Only the last one's correct.
Yes, that is what I chose. And I got like
Okay.
marked wrong. So,
That's something wrong with the portal. We'll
okay,
change
okay,
that thing.
okay. So, will we be remarked on that?
Yeah.
Okay, that's perfect. Thank you, ma'am.
Okay. So I'll end the session here. Thank you for joining.